Hello, students. Welcome to physics class. And in this physics class, we'll be looking at work, energy, and power. And this is a concept and aspect that is under mechanics in physics for Waec, for Neco, and for Jamb. And I want to have a basic understanding as regards this topic and be able to solve as many possible questions you have in your exams, like I said, for Jamb, for Waec, and for Neco. Now, when you talk about work, energy, and power, what do we need to understand about work, energy, and power? Work at first. When you talk about work, what do we understand about work? And we are going to look at that based on the explanation we are giving. Number one, let's talk about the definition of work. And work can be defined as work is said to be done when the point of application of force moves through a distance. What am I saying? You can see that work is said to be done when the point of application of a force moves through a distance, in the direction of the force. Now this is how we define work. Work is said to be done when the point of application of a force moves through a distance in the direction of the force, and that is how we can define work. And also, you can also look and see that work is also defined as the product of force and the distance traveled in the direction of the force. Like I said, this is what you need to understand about what work is all about. And also, work is a scalar quantity. Work is a scalar quantity, and that means that it has magnitude and no direction. It has only magnitude and no direction. That's why we say it is a scalar quantity. And from the definition we have defined, you can say that work is equal to force times distance. Work is equal to force times distance, and force is measured in Newton, while distance is measured in meter. So we can actually say that the unit of work is joules. From here we can see that we can say work is Newton meter. Newton for force and meter for distance. But the unit of work is joule. And you can have it in other units as kilojoule. You can have kilojoule, that's kg. You can also have megajoule, that's mg. So and so on like that. And kilojoule is 10 raised to power 3 joule, and megajoule is 10 raised to power 6 joules, as we can have it. And this is talking about the work done on the body. And let me explain a concept that we need to understand also about work to us. Now, when you're talking about work in physics, in physics, it's quite different from how you explain work to a layman. For a layman, work is done when you carry an object. Imagine you lift an object on your head And you might say that you are doing work. That is a layman explanation of work. But in science, when you put any object on, probably you are carrying any object and you are not moving, then you have not done any work. Because work is said to be done when the point of application of a force moves through a distance. Move through a distance. Now, when that has not been done, you have not done any work in physics. And also, as you can see, this work can also be related to the fact that when an object, when the point of application of force is not perpendicular to the distance, taking for instance, you have a force. Maybe you have a body here, which is a bus, and you want to drag this bus, and you are dragging it at an angle theta. So this is the force at which you are dragging it. So for us to get this force, you need to look at it from the vertical component and from the horizontal component. So we have what we refer to here as the vertical movement. Vertical movement, and here we have the horizontal movement. And we are going to look at it from the different perspectives. If the object moves vertically and also if it moves horizontally. How do you calculate it if it moves vertically and also it is moved horizontally? Also, we are going to look at other relationships that relates to work. And let's quickly explain that in this case. So when you're talking about still work being resolved into vertical component and horizontal component, we have established the fact that also, since we said that work is equals to force times distance, or force times distance s. Now, force itself is equals to mass times acceleration due to gravity. And in this case, we can refer to that, therefore we can say that work is equals to mg times x. And when you look at it from the angle of which it is going to draw, maybe drag at an angle theta to the horizontal. Now, we are going to look at it. That means we are going to have what we call the vertical force. And the vertical force is when this force is resolved to the vertical. And in that case, this is F, and here is F sin theta, while here is F cos theta. So in that case, we are going to have this as F sin theta, and therefore the work done is going to be force sin theta times distance, or we still say that mg sin theta times distance. Let's take note of the formula, because when the need arises, we know what we are applying and how to apply it. And also, when you look at the horizontal force, in that case, you can see that the work done is equal to F cos theta times distance, which is also equal to mg sin cos theta times distance. Also, let's take note of that formula, even with what we have explained there as well. All these are what we are going to apply when we are solving questions under work. As you can see, this explains what we need to understand as far as work is actually concerned. And the parameters that we have here, we know that work, we have mentioned it, work is in joules. So measure work in joules. We have M, which is equal to mass in kilogram. We have G, which is equal to acceleration due to gravity. And that is in meter per second squared, acceleration due to gravity. And we also have X, which is the distance traveled or distance covered in meters. Now, these are the things that we need to understand as far as work is concerned. You can see the way it has been explained to you before we move straight into various questions that will be explained under this. And if you find this video very interesting and very explanatory. I will ensure that you subscribe to this channel. This is coming from Covenant Achievers Academy. Now, what we are after here is to produce content like this for you, to produce what is necessary for you to pass your exam, to 8A, and to have higher score in your Jamb. And there is an ongoing free classes for now, which I want you to be part of it. If you have seen, this is just a tip or an high box of things that we are going to be explaining to you in the course of the lesson. I want to take this as an opportunity to make sure you join the class, and you are going to enjoy the class because you have access to ask questions. You have access to other aspects of physics, starting from the beginning of the syllabus of both Waec, Neco, and Jamb to the end of the syllabus. We are going to be dishing it out for you in details, explaining every concept that will make you to have, at least, you don't understand physics at all, you are going to be having something like 90 and above in your physics exam. And A is very easy for you to get in physics, Waec and Neco. A is very, very simple. So far you follow this channel. Follow, share, and subscribe, and be part of the lesson. You can see when you look at the comment section, under the comment section below, you have the email, the WhatsApp link that you are going to click to be part of the class. I'll be expecting you in class because more of it will be discussed for you in a demystified way. See you in class. Now let's talk about what is energy. We have actually explained what is work as we have seen in the explanation. Now we are looking at what is energy, as we have other work, energy and power for physics. And energy, we are going to be looking at it also the way we have explained work the other time. So let's look at firstly the definition. The definition of energy is the ability or capability to do work. Is the ability or capability to do work. So when we talk about energy, is the ability can be defined as either the ability to do work or the capability to do work. And here, that is what we can define as energy. Also, energy is a scalar quantity. Look at that stat. Energy is a scalar quantity. We have talked about what scalar quantity is. That means it has magnitude but no direction. It has magnitude but no direction. So we are going to also look at it that the SI unit of energy, the SI unit of energy is joule. And we have forms of energy. So what are the forms of energy that we have? We have mechanical energy, we have solar energy, we have wind energy, we have heat energy, we have sound energy, we have heat or thermal energy, we have nuclear energy, etc. So these are some of the forms of energy that we have. And on this, we are going to be looking at this mechanical energy. And the mechanical energy is divided into what we refer to as kinetic energy given as KE, and we have what we call the potential energy, that's PE, the kinetic energy and the potential energy. And that is what we are going to be looking at under the energy. So here we are going to focus more on what we refer to as the kinetic energy and also the potential energy. So when you talk about kinetic energy is the energy due to motion. Is the energy due to motion. When an object is subjected to motion, we are talking about kinetic energy. And while we have potential energy, is the energy due to position. Energy due to position, and that is potential energy that we need to know. And also, when you look at the kinetic energy, how do you calculate the kinetic energy? The kinetic energy is calculated as half mv squared, while the potential energy is calculated as mgh. So in this case, where m is equal to mass in kilogram and v is equal to velocity in meter per second. And the same thing here, we have m equals to mass in kilogram, and we have g equals to acceleration due to gravity. And we have h, which is equal to the height in meters. So we have all these concerning potential energy and kinetic energy that we need to know. Now, this is information that you need to understand before we actually go into the more calculations that we are going to be looking at. And you can see that we'll be referring back to the knowledge that we have, we understand as far as energy is concerned, as we explain the other aspects of the energy. And from there, we are still going to look at the other aspects of energy, which is going to talk about the law of conservation of energy. And when we talk about the law of conservation of energy, it actually states that energy in a closed system, energy can neither be created nor destroyed, but it can be transformed from one form to another. You can't create and destroy energy in a closed system, but it can be transformed from whatever form it is to another form. That means mechanical energy can be transformed into solar energy, solar energy can be transformed into any of the other energies. And we can see example of that in some of the appliances that we use. Taking for instance, your electric iron. What happened in the part of electric iron is it converted the electrical energy into heat energy. You can see you even part of the forms of energy. That's electrical energy. The bulb that you use is the electrical energy is converted into what? Light energy. Light energy is the part of the forms of energy. Light energy. So you can see that this is what the law of conservation of energy states, that energy can neither be created nor destroyed, but can be transformed from one form to what? Another. And that's the law of conservation of energy. And that shows that every energy can be transformed from wherever it is to another state. And just like another form, and that is what you can see in different appliances, different devices, different machines that takes place. And these are some of the things to be looking at when you are talking about energy. And here you are also going to look at, under the conservation of energy, how energy of a falling body and energy of a simple pendulum. When a body falls from a height, what happens to that? What energy conservation or what energy change has taken place? Initially, when an object is in a state of rest, that's the position. Like you said here, it is possessing the maximum potential energy because it is energy due to position. And when the object falls from a height to another height, no, at this point we are having the potential energy to be what? to the maximum because it is at rest and it is not moving, whereas the kinetic energy here is equal to 0. So immediately this object leaves this position, is dropping down like this, is dropping in that direction. We are going to see that the potential energy will be reducing and the kinetic energy will be increasing because it is now due to what? Motion. So the energy at which it strike the bottom or it strike the floor, at that point the kinetic energy is going to be maximum, while the potential energy is going to be what? 0. And in between the potential energy and the kinetic energy, as the object is coming, remember what I said, the potential energy is decreasing because the object is subjected to motion, while the kinetic energy is increasing because the object is also subjected to motion. So in between here, we are going to have the kinetic energy plus potential energy. So the energy is neither created nor destroyed, but it's transforming from one form to another. And same principle happens to a simple pendulum. When you subjected a ball to a pendulum to move to and fro, as the extreme end of the simple pendulum, we are having the maximum potential energy because it experiences rest. Now, at the peak of the pendulum ball, that's when you are having the maximum kinetic energy because at that time the movement is at the peak, and also in between we are having the potential energy and the kinetic energy, and that is what we need to understand under this aspect of energy. If this video, as you have enjoyed the video, ensure you subscribe, you like and you share. And what is it that we are going to be looking at? There is an online class that is going on presently, which I want to be part of it. Being part of it means that you are going to enjoy even far and more details of what we have here. This is just a tip that we are giving you here. And when you join the class, it's a free class going on for now, which is, you are going to see the link in the description below, which you are going to see the WhatsApp link. Click on the WhatsApp link and be part of the class. And other videos that have been released, you are going to see it. The major thing is that before you go, ensure you press the thumb up button and also share and like what you have seen. And this is coming from Covenant Achievers Academy, and we'll be demystifying and explain every aspect of the physics to you. Not only physics, chemistry is there, and also mathematics. If you have enjoyed this video once again, ensure you subscribe before we go into the next video. And stay tuned to watch the next video as it comes forth. Of power under the work, energy, and power. I've actually explained the concept of work, energy. Now we are looking at power in this episode. And now, what do we need to understand, or what is power? As you can see, power is the rate of doing work or the rate of energy transfer. So we can have that as we have for others. Let's look at the definition. Power is the rate of doing work or the rate of energy transferred. The rate of doing work or the rate of energy transfer, and that is what power is all about. And we have seen that in this case, how do you now calculate power? Power is equals to work done over time. Work done over time. And from there we can see that what is work done? Work done is equals to force times distance divided by time. And also we know that force is equals to mass times acceleration due to gravity. So we can as well define it as mg times x over time. And we can see that but velocity is equals to distance over time. So in that case, we can as well define power or work as power, W as, because force distance over time is velocity and mg is force. So you can define power as force times velocity. Let's take note of that relationship. Power can be taken as force times velocity. And the power, as you can see, it is measured in watts. The SI unit of power, the SI unit of power is watts. And we have other units of power. We can have kilowatts, which is 1000 watts, and is given as kilowatts. We have also megawatts, which is 1,000,000 watts, and that is megawatts, as the case may be. And this is how, or this is what we need to understand as far as power is concerned. And we are going to make use of this relationship that we have established here to solve various questions under power in physics. And we are going to be looking at it in a demystified way, step by step, as we enter into the question aspect of it. Now, if you have found this video very interesting, I want you to subscribe, like, and share this video. And also, there's an online class that is going on presently. It is free for all science students. And for you to be part of this, there is a WhatsApp link in the description below. Ensure you click on the WhatsApp link to join the class. Soon as you have joined the class, in that case, we'll be explaining and demystifying the whole concept of physics to you. And that will encourage and help and make you to score A. Now, having go through all this, I can assure you that you are not going to score, you are going to score nothing less than probably 90 and above. I assure you that you are going to score 90 and above in your physics. And this will give you upper hand in your exam. And that is why we focus on physics, mathematics, and chemistry in the tutorial. Now, the content, the link to join the tutorial once again is in the description below. Click on it and be part of it. And I'll be expecting you in that class. And also ensure you share this, like, and subscribe, as more of this will be coming. And we have explained work, energy has been explained, and this is part that is explained for you. The next aspect we are going into is the calculation aspect. Take your writing material, your calculator, and listen attentively to the next thing that we are going to be coming up, and that is going to be the calculation aspect. Just relax as you enjoy the calculation along with. We have in this question as well. This is question number 4. And here we have an engine raises 100 kilogram of water through a height of 60 meters. Let's begin to state the parameters. Now, what are the given parameters that we have here? We are given the mass. Mass M is equals to 100 kilogram of water through a height of 60 meters. We have the height, and the height h is 60 meters. In 20 seconds, time t is equals to 20 seconds. What is the power of the engine? And we are given G to be equals to 10 meters per second square. So we want to look at the power of the engine and how do you calculate that? Remember, we have established that power is equals to work done over time. Work done over time. So in that case, I know that work done is equals to force times distance over time. So what are the parameters that we have given? We know that force also is also equals to mass times accelerated due to gravity. That's mg times x divided by what? Time. So we could see we have the mass, accelerated due to gravity is given, we have the distance, and we have the time. So on substitution, what are we going to have here? We have this as mass is 100 times 10, then times distance. Distance is 60 meters divided by the time, which is 20 seconds. You can see. So we have 0 cancel 0, 2 goes there 1, 2 goes there 3. And in that case, you can see therefore the power is 1000 times 3, that's 3000 watts, or it's given as 3 kilowatts. So that's how we solve the question, as simple as it is. So far we have all the parameters of the question. Look at the question and look at the step-by-step way of solving the question. Once again, this is from Covenant Achievers Academy, and here we have solved a lot of questions for you to understand, both in mathematics, physics, and chemistry. And also, we have explained every aspect which is ongoing of the mathematics, physics, and chemistry, just like we have seen the way we solve this. And there is presently an online class that is going on, totally free for science students. How do you be part of it? Check the description below. You are going to see a WhatsApp link. Click on the WhatsApp link and it will direct you to the group. And then we'll be giving you every aspect of the subject, mathematics, physics, and chemistry, for you to have a deep understanding in those subjects. And that will help you in aiding your excellent score, both in Jamb, Waec, and Neco. Be part of it and just click on the WhatsApp link. And don't forget, subscribe, share, and like so that you have more of this as it's coming forth. Aspects, as you have explained it, we've discussed about work, we talk about energy, and we talk about power. Now, in this aspect, we are going to be looking at the calculations based on what we have discussed. And the question we have here is that a boy drags a bag of rice along a smooth horizontal floor with a force of 2 newtons. So let's take the parameters. What are the given data that we have? We are given the force. Force F as 2 newton. Apply at an angle theta. That means angle. Let's have it. Angle of inclination theta is equal to 60 degrees. To the floor, to the floor. The work done after a distance of 3 meters is, we are calculating the work done. Work done, that's W, is unknown. And we are given the distance. Distance x, which is equals to 3 meters. Now, you can see that this object is moved on a smooth horizontal floor, that is force along the horizontal floor. And you are moving it along, is a bag of rice is dragged with a force. And the angle of the inclination here is given as 60 degrees. So this is the force, which is the 2 newton. And you have to calculate it along horizontal floor. And here is going to be F cos theta. So from here, how do you calculate the work done? Work done is equal to F cos theta times X. And we are given all the parameters. What is F? That's 2 cos 60, then times half. Times distance, which is equals to 3. And from here, you could see that cos 60 is equals to 0.5. So we have 2 times 0.5, then times 3. And 2 times 0.5 is 1 times 3. So the answer is 3 joules. 3 joules of work is done. And that is our option B, as you can see here. That's how we solve the question. And you can see this is a Jamb question. Look at how simple it is. And this is what we'll be explaining and demystifying in the tutorial that I'm talking to you. This is an online class going on for now. Ensure you join the online class. It's a free class for all science students that are writing Jamb, Waec, and Neco. Ensure you are part of it to have a full details of what you need to understand as far as your exam is concerned for physics, for chemistry, and for mathematics. How do you join the class? There is a WhatsApp link in the description below. Click on it and be part of it. I'll be expecting you. A constant force of 40 newton. Now, given the parameters, let's see what the data that we are given. We are given the force. Force F is equals to 40 newton, acting on a body initially at rest. Initially at rest, meaning that the initial velocity, that's u, is 0 meter per second. Now, initially at rest, given an acceleration A equals to 0.1 meter per second square for 4 seconds. Time t is 4 seconds. Calculate the work done by the force. Calculate the work done. Work done, that's W, is unknown. And we know that the work done is equal to force times distance. But here we are not giving the distance, but we are giving the force. But we are giving other parameters to calculate the distance. From equation of motion, from equation of motion, we could see that x is equal to ut plus half at squared. And here we are giving u as 0, t is known. So this is u is equal to 0. So therefore, x is equal to half at squared. That means equals to 1 over 2. Acceleration is 0.1, then times t. T is, that's 4 square. And that's going to be 1 over 2 times 0.1 times 16. This cancelled this, that's 8, and that will give us 0.8 meters. So we have calculated the distance, which is x, 0.8 meter. Then this is the work done, which is equal to force, and that is 40 times 0.8, and that will give us 32 joules. 32 joules. You can see the way it has been solved in a demystified step-by-step way for you, and the final answer here is 32 joules. So from the option, C is the answer, as you can see, and that's how we solve it for you. Now, this is solution to physics questions, and more of it will be given to you. If you have enjoyed this as you have seen it, I will ensure that you subscribe, and also like and share. Now, there is something I want you to understand. There is presently an online tutorial, online lectures going on for all science students that are writing Jamb, Waec, and Neco. We want you to ace high in your exams, and that's why the tutorial is ongoing. It's online. For you to join, there is a WhatsApp link in the description below to join the group. Once you're able to click on it and you join the group, you'll be part of the class and you're going to enjoy a lot of questions. Questions, whenever you don't understand any aspect in your physics, just send it through the tutorial or send it through the WhatsApp group. We're going to demystify it for you and help you to understand every concept of physics, of mathematics, and also for Jamb. So in physics, mathematics, and chemistry, in your Waec, your Neco, and your Jamb, don't forget, click the WhatsApp link. But before you do that, ensure you subscribe. The question says that use the force distance diagram shown above, calculate the work done. Now, when you have a force distance diagram, that means relationship between force and distance. How do you calculate the work done? The work done under the force distance diagram, the work done under the force displacement diagram. Force displacement diagram is equals to area under the graph. And area under the graph, you can see when you plot this graph, this is the graph. This is when you have the area under the graph. So the area of this right angle triangle that we have here is going to determine the area under the graph. And when you look at it, the graph also gives us a rectangular shape because you are plotting force, which is this point, against distance, which is this point. So it's also this. So we are going to look at the total area under the graph, which is area of the rectangle. So this equals to area of the rectangle, area of the rectangle, and that is length times breadth. And the length times breadth here is 100 times 20, and that gives us 2,000 joules. 2,000 joules, or you can write it as 2 kilojoules. So that's how we solve that question. As simple as it is, like I said, we are going to be coming across various questions and solutions like this under this aspect of physics, also in mathematics, and also in chemistry. I want to be part of this. And how do you be part of this? Subscribe, so that whenever we post any video, you have access to it. Click the notification, the thumbs up button share it, and also like. And also, there is an online class, like I said, that is going on for now, and it is free, totally free. How do you be part of this? There is a WhatsApp link that we have created for you to click on. It takes you to the class, and once you are part of the group, you enjoy the same standard of question and how to solve, both for mathematics, for physics, and for chemistry, for your Jamb, Waec, Neco, and even advanced study. So do me fit to be part of this class by clicking on the WhatsApp link, but ensure you subscribe before you do that. Have an engine raises 100 kilogram of water through a height of 60 meters. Let's begin to state the parameters. Now, what are the given parameters that we have here? We are given the mass. Mass M is equals to 100 kilogram of water through a height of 60 meters. We have the height, and the height h is 60 meters. In 20 seconds, time t is equals to 20 seconds. What is the power of the engine? And we are given G to be equals to 10 meters per second square. So we want to look at the power of the engine, and how do you calculate that? Remember, we have established that power is equals to work done over time. Work done over time. So in that case, I know that work done is equals to force times distance over time. So what are the parameters that we have given? We know that force also is also equals to mass times accelerated due to gravity. That's mg times x divided by what? Time. So we could see we have the mass, accelerated due to gravity is given, we have the distance, and we have the time. So on substitution, what are we going to have here? We have this as mass is 100 times 10, then times distance. Distance is 60 meters divided by the time, which is 20 seconds. You can see. So we have 0 cancel 0, 2 goes there 1, 2 goes there 3. And in that case, you can see therefore the power is 1000 times 3, that's 3000 watts, or it's given as 3 kilowatts. So that's how we solve the question, as simple as it is. So far we have all the parameters of the question. Look at the question and look at the step-by-step way of solving the question. Once again, this is from Covenant Achievers Academy, and here we have solved a lot of questions for you to understand, both in mathematics, physics, and chemistry. And also we have explained every aspect which is ongoing of the mathematics, physics, and chemistry, just like we have seen the way we solve this. And there is presently an online class that is going on, totally free for science students. How do you be part of it? Check the description below. You are going to see a WhatsApp link. Click on the WhatsApp link and to direct you to the group. And then we'll be giving you every aspect of the subject, mathematics, physics, and chemistry, for you to have a deep understanding in those subjects. And that will help you in aiding your excellent score, both in Jamb, Waec, and Neco. Be part of it and just click on the WhatsApp link. And don't forget, subscribe, share, and like so that you have more of this as it's coming forth.